Welcome, class. Today we're going to cover quadratic equations and their parts. Our objective today is I can identify and graph the parts of a quadratic equation. The graphs of two quadratic functions are shown below. Complete each statement about the graphs. For part A down here, each graph of a curve is called a parabola. The highest point of graph A is located at -1, 4. That's this point right up here. So you go back 1, up 4, so it's -1, 4. And we write that over here as -1, comma, 4 in an ordered pair. This point is the maximum point of the graph. So that is your maximum. Alright, it is a maximum because it is the highest point on graph A that you can go if you were to trace it. For C down here, the lowest point of the graph is located at, or the lowest point of graph B is located right here, and that is -1, -2. You go back 1, down 2, so we write that as -1, -2. This point is called the minimum. And the reasoning behind that is if you trace the graph, it's the lowest point you'll reach before you start to go back up. On the next slide, the maximum or minimum point of the parabola is called the vertex. Oops, sorry about that. It is the vertex. The vertex of the parabola can also be called the turning point. I'm going to write that right underneath. If you fold a parabola along a line to get two halves that match exactly, the line where you fold the parabola is the axis of symmetry. This line goes through the vertex of the parabola. So let's flip back to that last slide and take a look at what this means on our graph. So we have this parabola here. I'm just gonna kind of trace that with my pen here. Okay, so we have this graph right here. And hold on, let me fix that. I apologize. Alright, here we go. Okay, so I'm going to trace this line, this parabola right here. And here we have, okay, our maximum at the top in blue, you kind of see here. I'm going to highlight that. Okay, our axis of symmetry is where it's going to cut this parabola directly in half. So if I were to fold your paper, or my paper, this parabola would lay right on top of each other. Okay, on the other side, you have your minimum. And again, the axis of symmetry goes right through the vertex. So this red line on graph B represents the axis of symmetry of B. If I fold that over on that line, the two parts of the parabola will be exactly the same. Okay, so going back here with what we just talked about. Okay, if you fold the parabola along a line to get two equal parts, then okay, we have our axis of symmetry, which goes right through the vertex every time. Number 5. For a quadratic function y equals ax squared plus bx plus c, the parabola opens upward if a is greater than 0. And the parabola opens downward if a is less than 0, which is very important for us to remember. Alright, so the standard form equation of a quadratic is f of x equals ax squared plus bx plus c. This is very similar to y equals mx plus b for a linear equation, except for this is for quadratics now. Okay, the x value of the vertex is -b over 2a, and to find the y value, we have to plug it back in. And we're going to go over that in the example right below. Okay, the y-intercept is c. Okay, it's always your c value. So up here, I want you to circle c and write an arrow and say that's your y-intercept every time. Okay, and then the axis of symmetry is x equals negative b over 2a. And that is an important formula to know. Okay, you do not have to memorize it, but if you do know it, it will save you a lot of trouble. Alright, so for the example below, okay, we're going to need to find the axis of symmetry, the vertex, and the y-intercept. So I'm going to start with the y-intercept because that's the easiest. That's your c value. So your y-intercept is your last value here, which is your y-intercept, is negative 10. So your y-intercept is negative 10. So your y-intercept is negative 10. Okay. Your a value is 3. So you need to know your a, b, and c values. So if you look up here, your a value is always what's in front of the x squared. So that's going to be 3. Your b value is always what's in front of the plain old x, or x to the first. So down here, that's going to be 18. And your c value is always your y-intercept, or the c value. So your c value is negative 10. So once you know all of that, now we can just go ahead and plug into our formula. So we're going to find the axis of symmetry next. So for axis of symmetry, x equals negative b over 2a. So negative b, so b is 18. So in our formula we have a negative, so we need it negative. And then our b value is 18, so that becomes negative 18 over 2, which is part of our formula, times our a value, which is 3. Okay, and when we simplify this, we get negative 18 divided by 2 times 3, which is 6. And then negative 18 divided by 6 is negative 3. Alright, so when we have x equals negative 3 as our final part for the axis of symmetry, that is the equation of our axis of symmetry, x equals negative 3. So that's also the x value of our vertex. So I'm going to write this as AOS, axis of symmetry. Okay. Our vertex now, I'm going to scroll down a little bit so I can do it. Okay, so for the vertex, I want you to realize it's always written as a point. Okay, it's either your maximum or your minimum point. And we know that the axis of symmetry, okay, is always our x value of our vertex. So to find the y value of the vertex, what we need to do is we need to take our original equation, okay, and we need to plug everything back into it. So we take y equals 3x squared plus 18x minus 10. Then we plug negative 3 in. So we do y equals 3 times negative 3, and that's squared, plus 18 times negative 3 again, and then we tack on our minus 10. Then we need to go through and simplify. So y equals 3 times negative 3 squared is a positive 9, because negative 3 times negative 3 is 9. 18 times negative 3 is minus 54. And we subtract 10 at the end. And now we have y equals 3 times 9 is 27, and we have a minus 54 and a minus 10. So y equals, when you plug that into your calculator, you should get negative 37. So our y value of our vertex is negative 37. So our vertex is negative 3, negative 37. And that's the three parts that I asked you to find. Alright, in general, okay, there's a few things that we need to remember while we do quadratics. Okay? If a is positive, which we talked about earlier, we know that the graph opens upward. Okay, so what I want you to see is that if I draw an x and a y axis, okay, and I'm going to draw two because I'm going to need one over here in a minute, or the other one. And up here we're going to have a greater than 0, and over here we're going to have a less than 0. And I want you to see what happens. So when a is greater than 0, our parabola opens up. So we have a smiley face. So I draw this little diagram so it has a little face. You can see that when it's bigger than 0, so when a is a positive number, it's a smiley face. When it is less than 0 or a negative number, we get a sad face or a frowning face. Right. If the a value is between -1 and 1, okay, we realize that the graph gets a lot wider. Okay, the bigger a is, so if a is like 8, 9, 10, 15, the graph is really narrow. And then the last part that this slide shows us is to find x-intercepts, which are also called zeros, we set the function equal to 0. That part we will take a look at in our next lesson. The last two slides are going to go through two examples of how to graph a quadratic equation. So this first example, okay, it says graph f of x equals 2x squared plus 2x minus 2. Label the axis of symmetry and the vertex. So the first thing we need to do is take everything we just learned and put it all together. Okay, when we have a graph, we always want to check what is our y-intercept. So let's check our y-intercept first. Okay, we know that our y-intercept up here is a c value, so our y-intercept is -2. So y equals, or y, sorry, not y equals, y-intercept is -2. So look at your graphs. The y-intercept here is -2. The y-intercept over here is +2. So if it's a +2, we know that can't be the right graph, so we need to automatically x this one out. In the last graph, our y-intercept is also -2. Then, once we have our y-intercept and we've narrowed down hopefully at least one graph, we need to move on. So now we need to look at the axis of symmetry. So where should the x value of that vertex be? Okay, so we're going to do x equals -b over 2a. And just as a reminder, off to the side I'm going to write my a value, and that's in front of the x squared, which is 2, my b value, which is in front of the x, which is also 2 in this case, and my c value, which is what we talked about as our y-intercept, is -2. So over here, x equals -2 over 2 times 2, because those are our values. So we do -2 over 4, which reduces to -1/2 or -0.5. So then we take a look. Okay, which one of these equations, okay, goes through x equals -0.5 or -1/2? And we take a look. Well, A, we notice that the axis of symmetry is right here, but that goes through a value on the positive x-axis, and it looks like a positive 0.5. So then it cannot be it, because our axis of symmetry is -0.5. So where's my x -0.5? That would be, oh, looks like right here. That would be this equation. And that is that's answer D. So that is the correct answer. Okay, down here, we want to double check. Axis of symmetry is -0.5. That is correct. And our vertex, right, should be -0.5, -2.5. If we go through and we plug in to our equation, okay, -0.5, we should get -2.5 as the other value to our vertex. So I'm going to show you that here. It is not necessary that you do that, but it is something that you may have to do eventually. So f of -0.5 equals, and I'm going to write that right down here, 2 times negative 0.5 squared plus 2 times negative 0.5 minus 2. Right, you plug all that into your calculator and you should get f of negative 0.5 equals negative 2.5. Now that's just a quick check. Okay, so you know that is your answer. And you are done. And then the last example. Alright. So in this example, right, we are going to see the graph y equals negative x squared minus 4x minus 3, and we're going to need to pick which graph goes with that. So again, we should start with our y-intercepts. So we know our y-intercept is our c value, which is negative 3. Okay, that is our y-intercept. So I'm going to look at which one of these graphs goes through to y equals negative 3. So this one goes through right here on positive 3, so that's not it. Okay, this one goes through again on positive 3, so that can't be the right graph. This one here goes through negative 3, so that's a possibility. And this one goes through negative 3, so that is also a possibility. So the next thing I want you to check for is x equals negative b over 2a, which is your axis of symmetry. Okay, so our b value is in front of the x, which is negative 4, and our a value is negative 1, which is in front of the x squared. So this equals, and in the formula we have a negative. Okay, we also have a negative in our b value, so it's negative 4 divided by 2 times whatever a value is, which happens to also be a negative 1. So negative 4 turns into a positive 4 over 2 times negative 1, which is negative 2. So our axis of symmetry is x equals negative 2. So which one of these graphs has an axis of symmetry of negative 2? If we look at this one, it looks like our axis of symmetry is negative 2. So we think that is right. Let's check this one. Over here, our axis of symmetry is positive 2. So we know that is not right. So our answer is number 2. And that is all we have for today.